Hey guys, welcome back to our channel. So today we're going to be talking about the 6 trig functions. Now let's look at SOHCAHTOA. So in SOHCAHTOA, it goes to sine. This is opposite over hypotenuse. Now COS, which goes for adjacent over hypotenuse. And now tangent, TOA, which is opposite over adjacent. Now, 3 new ones you shouldn't have learned yet, but you probably will learn in pre-calc are cosecant, secant, and cotangent. So this is basically like reversed. This is hypotenuse over opposite. This is hypotenuse over adjacent. And this is adjacent over opposite. Now let's look at a quick example. Also, something I want to discuss is cosecant, secant, and cotangent are also basically reciprocal functions of sine. It's like this would be 1 over sine. This would be 1 over cosine. This would be 1 over tan. Now let's move on to the example. So looking at the sine in this, the angle is right here. So we have our opposite side, our hypotenuse, and our adjacent right here. So this would be 12 over 13. The cosine would be 5 over 13. And the tangent would be 12 over 5. Now looking at the cosecant, it would be flipped. It would just be 13 over 12, 13 over 5, and 5 over 12. So something else I'd like to discuss is sines of trig functions. So if you're familiar with this phrase, it's all students take calc. This will help you figure out what sine of the trig function you're looking at. So in quadrant 1, all trig functions are positive. In quadrant 2, only sine is, and cosecant. In quadrant 3, it's tan and cotangent. In quadrant 4, it's cosine and secant. Hey guys, welcome back to our channel. So today we're going to be talking about the sine and cosine graphs. So the sine graph always starts at your midline. In this case, it's the origin. And then at pi over 2, it hits your maximum at 1 and comes back down for x-intercept and then goes all the way to the bottom, hitting its minimum. And it's the same on this side. So the domain of this would be all real numbers. The range would be -1 to 1. The x-intercept would be x equals n pi, n being integers. And that's going to this actually, the E symbol. So if you're looking at this graph, you see this is 0, and then this is pi, and this is 2 pi. You're adding a pi every single time, or you're subtracting a pi to get the next x-intercept. Now looking at the y-intercept, it's at the origin 0, 0. There's none asymptotes, and there is a 1 amplitude, so that would be this part of the graph. And the period is 2 pi, because this whole portion of the graph is 1 cycle, or 1 period. And looking at the transformations of a sine graph, this is the amplitude. This would be absolute value of A. This divided by 2 pi over B is equal to period. This is vertical shift. Now this is your horizontal shift. X minus h is shifted to the right. X plus h is shifted to the left. And that's it for our sine graph. So in a cosine graph, you're always going to start off at the amplitude. And then you're going to come back down for x-intercept at the pi over 2. And then hit your minimum at pi. Come back up and hit your maximum again. And it's the same on this side. So look at the domain. It's all real numbers, just like sine has the same range, but its x-intercepts are different. It's x equals n over pi plus pi over 2. And so if you look at this is pi over 2, and essentially you're just adding 2 pi over 2, making it 3 pi over 2 every single time. And now looking at the y-intercept, it's at 0, 1, the maximum. There's no asymptotes, and the amplitude is 1, and the period is 2 pi. Now it has the exact same transformations as a sine graph. This is 2 pi over b being period, horizontal shift, and vertical. And that's it for today's video. Thank you for watching, and please let us know if you have any other things you would like us to discuss or even do problems on.